Hi, today we gonna present about project progression 1. Currently, we are conducting on in-depth study on the working of few-shot learning methodologies. Our primary focus is on evaluating the accuracy and efficiency of the Siamese model in this context. And we train using our senior dataset and supplemented it with the additional image we sought. Out of the initial 26,737 images, we narrow it down to 6,963 for training. And here are the example of dataset we use for training. The first one is from my senior dataset that used for his project, and the second is the dataset we personally collected. For training, we use Siamese network. Siamese network utilize two or more identical subnetwork with the same parameters and weight. This ensures both input undergo the same transformation, making them ideal for task comparing the similarity or relationship between items. We utilize Inception ResNet v2 for our CNN. This architecture merged the benefit of Inception network, which focus on various spatial hierarchy of an image, which the ResNet re- residual connection that counteract the vanish gradient issue in deep network. For testing, we use 135 shot 8-way approach. This means we have 1, 3, or 5 different images for each dog class, and the system will predict which of these different images is most similar to the output to the input. Here is it an example of testing dataset. As you can see, if the dog 3321002 is looking to the right, the system might mistakenly predict it as dog 3321001. To enhance the accuracy, it is beneficially to have the accurate different images for better output prediction. And also we use 2897 images for training.
For the problem, we encounter several challenges. First, after installing Visual Studio Code, we face missing library issue, which we resolve by installing the library Visual via the command prompts. Second, our computational models couldn't leverage GPU acceleration, making it incompatible with TensorFlow load model function. So we had to rely on CPU-based training. And lastly, upon receiving low accuracy, we adjust the dataset image, leading to improved output accuracy. This is our training result. The K-fold cost validation graph. Graph in the left are training and validation loss, and in the right are training and validation accuracy. For this, we have threefold, which mean threefold cost validation graph. For how it works is that in the first iteration, fold 1 serves as the validation set, while fold 2 and 3 are combined and used as the training set. And for the second and third iteration, fold 2 and fold 3 will serve as a validation, while the rest will be served as the training set. Next are the cluster graph. Each color represents each class of dogs which are in high dimensional space. The distance between each cluster gives some sense of the relative dissimilarity between the group in the high dimensional space. Another result are the accuracy result from testing, which we have 1 shot, 8-way, 3 shot, 8-way, and lastly 5 shot, 8-way. For 1 shot, we use one support set from each class of picture, which give accuracy of 0.83, and for 3 shot and 5 shot, we use 3 and 5 support set from each class of the picture, which give the accuracy results of 0.87 and 0.77 respectively. For conclusion, from our progress, we take a time mostly with the Siamese network. At last, we achieve accuracy rate exceeding 60% across various tests and datasets. So next, for our upcoming research, we aim to compare their performance to another model to find more effective few-shot learning models. Thank you.